everyone. In this video, I'm going to talk about explicit formulas and recursive formulas of sequences. In this video, we will learn how to find a specific term by using an explicit formula and a recursive formula. Besides that, we will learn how to find the explicit formula and the recursive formula of a sequence given. If you find that this video is useful, please share to your friends, to your students, or to anybody who needs this. If this is your first time here, make sure you subscribe my channel by hitting the subscribe button below so that you won't miss any videos later. So, let's start the lesson right now. In this video, I'm going to talk about one of the subtopics in sequence and series, that is explicit formulas and recursive formula. So now our learning outcome is students should be able to use an explicit formula and a recursive formula for a sequence. So now we start from the explicit formula. What is explicit formulas? Explicit formula is the formula that we can use the formula to calculate any term in a sequence directly without going to any value of term before it. So, for example here, the n term of a sequence is given by un equals 2n minus 1 for n greater than or equal to 1. Find the 20th term. In this question, this un is explicit formula for the sequence. So, since we want to find the value of the 20th term, so we simply substitute the value of n with 20. So, means when n it is equal to 20, and when we simplify, that is 39. So, the 20th term is 39. So we can simply substitute the value of n directly. Okay, so now for recursive formulas. For recursive formula, if you want to find any term in a sequence, you are not able to find the value of term directly, but you must base on the previous term, that is the term before it. And normally, you will be given the first term for you to start the calculation. So, for example, find the fifth term of the recursive formula given here. Then you are given that the first term is 8. So, from the formula, how do we know that that is a recursive formula? Now, when we look at here, un is equal to 2un minus 1 plus 3. So, un is depends on 2 un minus 1 plus 3. So when we look at the number line, un, the previous term is un minus 1. So if we want to find the value of un, we must know the value of un minus 1. That is the previous term. So un depends on the previous term, that is n minus 1. So this is the recursive formula. So means if you want to find fifth term, you are not able to find the fifth term directly, but you must go through, you must start from the first term given, that is u1 is equal to 8, then followed by u2. So if you want to find u2, you must look at the recursive formula given. If the recursive formula is un, so un compared with u2, so n is equal to 2. So when doing the calculation, all the value of n in this case is equal to 2. So 2 minus 1, so this one is 2 times u1 plus 3. So the value of u1 is 8. So when we simplify, it is 19. Then we go to u3. So u3 compared with un, so n is equal to 3. So when we're doing the calculation, n is 3, 3 minus 1, so it is equal to 2 times u2 plus 3. So the value of u2 is 19, so when we substitute and simplify, u3 is 41. Then followed by u4. u4 compared with un, n is 4. So when doing the calculation, n is 4, 4 minus 1, it is u3. u4 is equal to 2u3 plus 3, and the value of u3 is 41. So when we simplify, that is 85. Now, then only you can calculate the value of u5, that is the fifth term in the sequence. So u5, when we compare with the recursive formula un, n is 5. So when doing the calculation, n is 5, 5 minus 1, so u5 is equal to 2 times u4 plus 3. So value of u4 is 85, and when we simplify, then u5 is 173. So therefore, the fifth term of the sequence is 173. So when we look at this recursive formula, the recursive formula is given un, but not all the time recursive formula is given in un. Now we look at the next example. So the example number 3, find the fourth term of the recursive formula given un plus 1 equals n times un minus n. You're given the first term is 3. So when we look at the recursive formula, it is not for un, it is for un plus 1. So when we look at the number line, un plus 1, if we want to calculate un plus 1, it depends on un, that is the previous term. So means this is the recursive formula. So we must start from the first term given, that is u1. u1 is 3, then followed by u2. Then if we want to find u2, the recursive formula, we must look at the recursive formula given. Since the recursive formula given is un plus 1, so n plus 1 is equal to 2. So in this case, n is equal to 1, because 1 plus 1 is 2. So if when doing the calculation, the value of n, we must substitute with 1 to do the calculation. So n is 1, un is u1, n is 1 minus 1. So u1 is given as 3. So when we simplify, u2 is 2. So next we go to u3. So u3 compare with un plus 1. So n plus 1 equals to 3. So in this case, n is equal to 2. So when doing the calculation in this case, all the value of n, we must substitute with 2. So 2 times un is u2 minus n is minus 2. So u2, we can get it from here. So when we simplify, u3 is 2. Then only you can go to u4. So when we compare with the recursive formula, u4, 4 is n plus 1. So in this case, n is equal to 3. So when doing the calculation, all the n, now you have to substitute with 3. So 3 u3 minus 3. So u3, you can get it from here. Then when you simplify, it is equal to 3. So therefore, the fourth term in this sequence is 3. Now we look at another example. In this example, the recursive formula given is un plus 2 equals 3 times un plus 1 minus 2 un. So in this recursive formula, if we want to find the any term, we can see here it depends on two terms. When we look at the number line, n plus 2 is here, n plus 1 is the previous term of n plus 2, un is the previous term of n plus 1. So if we want to find the term n plus 2, it depends on two terms before it. So if depends on two terms before it, so the question will be given two value of u1 and u2. So u1 is 1, u2 is 3. Now, if we want to find the fourth term, we are not able to directly go to fourth term. We must calculate term number 3. So, for term number 3, U3, we must look at the recursive formula given here. 3, this is n plus 2. So, 3, we must separate into 1 plus 2. So, means n is equal to 1. So, when doing the calculation, all the n now you replace with 1. So, means U3 is equal to 3 times U2 because n is 1 minus 2U1. So, the value of U1 and U2 is given. So, when we simplify, that is 7. Then, after the U3, now then only we can go to U4. So, when we compare U4 with UN plus 2, n plus 2 is 4. So, in this case, n is 2. So, when doing the calculation in this case, n must replace with 2. So, means U4 is equal to 3 times U3 because n is 2 minus 2 U2. So, value of U2 and U3 you can get it from here. So, when we simplify, U4 is 15. So, therefore, the fourth term is equal to 15. In question number 2, number 3, and number 4, you are given the recursive formula or explicit formula of a sequence and you are asked to find a specific term. Now the following example, that is, you are going to do the reverse process, that is, you will be given the sequence and then based on the sequence, you will ask to find the explicit formula or the recursive formula of the sequence. Now let's look at the example number 5. Find an explicit and a recursive formula for the sequence given here. So when we look at the sequence, the first term is 10, go to 15, 20, and 25. So from 10 becomes 15, we plus 5. 10 plus 5, 15. So 15, same thing, plus 5 becomes 20. Then 20 plus 5 becomes 25. So here we can see that it is a GP. So the common difference is 5. So for common difference is 5. For formula of explicit formula for AP, that is UN equals A plus n minus 1 d. A is the first term, d is the common difference. So when we substitute the A with 10, that is the first term, n minus 1, d is the common difference, and when we simplify, that is 5n plus 5. So this is the formula for the explicit formula for the sequence. So next, for recursive formula, so recursive formula, we always start from the first term, that is 10. Then for recursive formula for UN, so when we look at the number line, for recursive formula UN will always depends on the previous term. So previous term of UN is UN minus 1. So from here, when we look at the change of the number, we know that from the previous term UN minus 1, we plus 5 in order to get the next term, that is UN. So from here, in order to find UN, we use UN minus 1, that is the previous term, plus the common difference, that is 5. So that's it. This is the recursive formula for this sequence. Then we need to write down n started from 2 and greater than 2. Or I can also use another alternative, that is I can use UN plus 1. So if I want to find UN plus 1, n plus 1, the previous term is UN. So from UN, if we want to find n plus 1, we know that we must plus 5. So in order to find n plus 1 using un, so un plus 5. So this one also can be considered as the recursive formula, and the only different thing is for un plus 1, for the second term u2, n is equal to 1 because 1 plus 1 is 2, so means n start from 1. So we look at the next example. Find an explicit and a recursive formula of the n term for the sequence given here. So when we look at this sequence, first term is 48, second term is 24. In order to find the second term based on the first term 48, we multiply 1 over 2. From 24 to 12, same thing, we multiply with 1 over 2. From 12 to 6, we multiply with 1 over 2. So this is GP, means the common ratio is equal to 1 over 2. So in this case, to find the explicit formula, we use the formula for GP. Un equals AR n minus 1. A is the first term, R is the common ratio. So when we substitute A with 48, R with 1 over 2, then this is the explicit formula for the sequence. Then next, for recursive formula. For recursive formula, we always start from the first term, U1 is 48. Then for this sequence, for the recursive formula for UN, so when we look at the number line, UN will always depends on the previous term, that is UN minus 1. So from the pattern of the number in this sequence, we know that in order to find the next term, start from the previous term, we multiply with 1 over 2. So means if you want to find UN based on UN minus 1, we multiply with 1 over 2. So when we simplify, UN is equal to 1 over 2 UN minus 1. Then we write down n start from 2 because first term is 1, second term UN, so n start from 2. So in this question, even though UN plus 1 equals 1 over 2 times UN is also considered as the recursive formula, but because the question requests for the recursive formula of the n term, so means your final answer should be UN. Now in example number 5 and example number 6, you are given the sequence and asked to find the formula. But for the next example, now we look at the next example, you are given the explicit formula and you are asked to find the recursive formula of the sequence. So you are given that the n term of a sequence is given by UN equals 3n plus 5. So UN equals 3n plus 5 is explicit formula. Then find a recursive formula of the n term. So this question asks for a recursive formula because explicit formula already given. But the recursive formula is only for n term, means you need to find the recursive formula for UN. So actually we have two methods you can use to find the recursive formula. First method, we can list out the number in the sequence. The first term, n is equal to 1, 3 times 1 plus 5 is 8. The second term, n is equal to 2, 3 times 2 plus 5 is 11. Third term, n is equal to 3, 3 times 3 plus 5, 14. And the fourth term is 17. So from the first term plus 3, we get second term. From second term plus 3, we get third term. From third term plus 3, we get fourth term. So it is very clear that the sequence is an AP. Now that is the common difference is 3. Then next, you don't have to find the explicit formula because explicit formula already given here. Now you have to find the recursive formula. So recursive formula, we always start from the first term, that is 8. Since the recursive formula of the question asks for recursive formula of n term, so means you are asked to find the recursive formula for un. So when we look at the number line, un, the previous term is un minus 1. So to find the n minus 1, when we look at the number here, so every time from the previous term, we must plus 3 to get the next term. So means from un minus 1, we plus 3 to get un. So in order to get un, so we start from un minus 1 plus 3. So now this is the recursive formula of the sequence. Then we write down n start from 2 because this is the second term, n is equal to 2. Next, we have also another method you can use to find the recursive formula, that is we use algebra method. We don't list out the number here. Okay, for algebra method, we know that we want to find recursive formula for un. So un is depends on the previous term, that is un minus 1. So un, we have got it. Then means we still short of the un minus 1. So means the first step is you must find un minus 1. So to find un minus 1, we based on the explicit formula un equals 3n plus 5. So when we compare the un with un minus 1, so to find un minus 1, we simply replace the original n with n minus 1. So here 3n plus 5, so we can replace with 3n minus 1 plus 5. Then we try to expand. So when we expand, we get 3n minus 3 plus 5. So the following step, please do not simplify negative 3 plus 5 becomes 2. What you should do is you should rearrange the equation so that plus 5, you can see 3n plus 5. Why? Because when 3n plus 5, so when we compare with the explicit formula just now, 3n plus 5, actually you can replace with un. So when 3n plus 5 replace with un, then we will get this equation. But this equation, it is not the recursive formula that we want, because the recursive formula asks for un. Another reason is when we look at this equation, it seems that un minus 1 depends on un. n minus 1 is the term on the left. It seems like the term on the left depends on the term on the right, so it is not correct. So for recursive formula, should be the term on the right depends on the term on the left. So means we need to shift the 3 to the left hand side, becomes un equals un minus 1 plus 3. So means the term on the right hand side un depends on the term on the left hand side n minus 1. Then finally we write down the first term and n start from 2. So this is the recursive formula for the sequence. And for this question, even though un plus 1 equals un plus 3 is also recursive formula, but this is not the answer because the question already mentioned very clear. The question asked for recursive formula for un. So you should give your answer un equals un minus 1 plus 3. Next, the n term of a sequence is given by un equals 5, times 2 power n minus 1. So this is the explicit formula of the sequence. Now the question is express un plus 1 in terms of un. So when we look at this question, this question never mentioned about the recursive formula, but actually this question asks for recursive formula because express un plus 1 in terms of un means your final answer is un plus 1 equals something un. So means un plus 1 depends on un, that is the previous term. So means actually this question asks for recursive formula. So same thing, you have two methods. First, you can list down the sequence. The first term n is equal to 1, it is 5. When second term n equals to 2, it is 10. Third term n is 3, it is 20. Fourth term n is 4, it is 40. So when we look at the number, so from first term to second term, we multiply 2. From second term to third term, multiply 2. Third term to fourth term, multiply 2. So means we can see that this is a GP, so that the common ratio is 2. So now, since the question never mentioned about recursive formula, the question asks for un plus 1, so we don't write the recursive formula, we write un plus 1. So when we look at here, un plus 1 depends on un. So from the number here, we know that from the previous term to calculate the next term, we multiply with 2. So to calculate un plus 1, we base on un multiply 2. So un multiply 2. So finally, the answer is un plus 1 equals 2un. So this is what the question asks for, that is express un plus 1 in terms of un, that is un plus 1 in terms of un, that is equal to 2un. So next method, we can use algebra method, that is we want to find un plus 1. So to find un plus 1, we can make use of the explicit formula. From the explicit formula, the original n we can replace with n plus 1. The original n here, same thing, we can replace with n plus 1. But when you come to this step, remember, do not simplify. Plus 1 minus 1 becomes 0, becomes 2 power n. No, do not simplify. So what you should do is, you look at the explicit formula, you need 2n minus 1. So here, same thing, you need to rearrange the power, becomes 2 power n minus 1. Then now you have an extra plus 1 here. So this extra index you need to separate from the 2n minus 1. So when we separate the power 1, so 2 power 1 is 2. So after you separate the power positive 1 becomes 2. So when you see this part, 5 times 2 power n minus 1, it is exactly as the explicit formula un. So means this part you can substitute with un times 2. So it is 2un. Then, therefore, you can write your final answer. Un plus 1 is equal to 2un. Here you don't have to write your recursive formula is u1 then un plus 1, because the question doesn't ask for recursive formula. The question only asks you to express un plus 1 in terms of un. So once you have successfully expressed un plus 1 in terms of un, then that's it, your answer. Now next we go to the next example. The sum of the first n terms of a sequence is given by Sn equals 3n power 2 minus n. So find an explicit and a recursive formula for un. So for this question, you are given the sum of first n term. Compare with the example number 8 and example number 7, you are given the explicit formula. But now, you are given the sum of first n term Sn. So, this question asks for explicit formula and a recursive formula for un. So, first we go to explicit formula. So, to find the explicit formula for un, you can use this formula. Un is equal to Sn minus Sn minus 1. So, since Sn is given, means the first step you need to find Sn minus 1. So, to find Sn minus 1, compare with Sn, we simply replace the original n with n minus 1. So, Sn minus 1, 3n. So, this n replaced with n minus 1. This is original n replaced with n minus 1. So, when we simplify, we will get this. Now, we have Sn and Sn minus 1. So, we can use these two expressions to find un. So, therefore, un is Sn, 3n power 2 minus n minus Sn minus 1. That is 3n power 2 minus 7n plus 4. So, when we simplify, we will get 6n minus 4. So, 6n minus 4 is the explicit formula. Okay, so un. Explicit formula, the question asks for un. So, un is equal to 6n minus 4. So, next, for the recursive formula, since the recursive formula asks for un, so we know that recursive formula un depends on the previous term, that is un minus 1. So means the first thing we need to calculate is un minus 1. In order to find un minus 1, we make use of un just now. So the original n, now you substitute with n minus 1. So when we expand, remember, we do not simplify this one. Okay, instead of that, we rearrange 4 in front, because 6n minus 4, when we compare with the explicit formula, it is un. So, 6n minus 4 can be replaced with un. So, now we have un minus 1 equals un minus 6. But this is not your final answer, because the question asks for the recursive formula for un. So, means you need to rearrange the equation, becomes un equals un minus 1 plus 6. So, therefore, the recursive formula is un equals un minus 1 plus 6. And please mention the first term. First term is u1. You use the n, substitute with 1, then 6 minus 4 is 2. So, first term is 2. So, this is the recursive formula. So, that's all for now. Do you understand what you learned today? If you have any question, let me know in Teacher Eileen Maths group. If you find that this video is useful, hit the like button. Don't forget to subscribe. Thank you so much for watching. I hope you keep on learning and keep on watching my videos. And I hope to see you soon. Bye.